Hello everyone. In this video we're going to be solving a very interesting equation from USA TST for IMO, which means the United States of America team selection test for the International Math Olympiads. So we have this equation 1 over x squared plus 1 over the square root, 1 over 4 minus the square root of 3x squared equals 1. And we're going to be looking for x values. So to be able to solve this equation, actually, we're going to try to use a well-known identity from trigonometry, which I think makes this equation pretty interesting. And obviously, there's a reason why this works nicely. So we're going to go ahead and do the following. We're going to set x equal to secant of theta. In other words, 1 over cosine theta. And the reason behind that is if you call x 1 over cosine, from here 1 over x becomes cosine theta. And as you can see here, we have 1 over x squared, which means when we square cosine, we get cosine squared. And then, of course, sine squared plus cosine squared is equal to 1. So if this is cosine squared, then the other expression must be sine squared, which means from here we get sine theta is equal to 1 over 4 minus the square root of 3 multiplied by x. Make sense? So here's what we have so far. Since we said that, okay, x is 1 over cosine theta, so cosine theta in this case is going to be 1 over x from here, and sine theta is going to be 1 over 4 times the square root of 3x. So let's go ahead and kind of put this all together and then see what we're going to get from here. So best way to approach it is probably replace the x here with 1 over cosine theta, and we have the x here, so sine theta is equal to 1 over 4 minus square root of 3 times x, which is 1 over cosine theta. And then we're going to come up with a really nice equation from here, and we're going to try to solve that one, okay? And of course, by solving for theta, we're kind of solving for x, and we'll get back to it. So let's go ahead and do this correctly. First of all, one thing you can do, I think that'll be very helpful, is multiply the numerator and the denominator by cosine theta, and by distributing, you kind of get rid of the fraction. This is going to give you 4 cosine theta minus, and these two are going to cancel out, minus root 3, okay? Now, let's go ahead and kind of distribute, multiply, whatever, and try to simplify this, okay? If you go ahead and cross multiply here, you're going to get 4 sine theta cosine theta minus square root of 3 sine theta is equal to cosine theta. Awesome. Now, let's go ahead and put it in a nicer form. First of all, here's what I'd like you to notice. We have a special expression here. If you are familiar with double angle formulas, you should know that sine of 2 theta can be written as 2 sine theta cosine theta. We also have a formula for cosine, but we don't use that here. And then we're going to go ahead and add this to both sides. So let's go ahead and do that. And we're going to make it even better. So let me go ahead and add square root of 3 sine theta to both sides. So we're going to get this. And guess what? 2 sine theta cosine theta is what I need. So let's go ahead and multiply both sides by 1/2 or just divide by 2. That's going to give us really cool stuff because it's going to be 2 sine theta cosine theta, which I can turn into sine of 2 theta. And on the right-hand side, we actually have something. This is why this problem works so nicely. We have a very, very special expression, okay? So let me go ahead and, first of all, split this up. Now, why is this so special? Because you can actually go ahead and replace 1/2 with the cosine of an angle and square root of 3 over 2 by the sine of the same angle. So we can kind of come up with a really nice formula. That's how this problem was designed, basically, right? By people who wrote this problem. By the way, this is a team selection test, which means a number of students will take the test, and then by using the results, I think they choose the top 12, and then from that, they're going to choose the team. Anyways, so let's go ahead and call this cosine of Okay, well, cosine of which angle is equal to 1/2? If you think about it, that's going to be sine 30 or cosine 60, which is pi over 3. So this is cosine pi over 3. At the same time, this is sine of pi over 3, right? So here's what we have now. Cosine of theta cosine of pi over 3 plus sine of theta times sine of pi over 3. And on the left-hand side, which is now on the right-hand side, we have sine of 2 theta. And you might still be questioning, like, so what, right? How is this going to help? Well, if you're familiar with the formulas for the sum and difference formulas, you're going to realize, hopefully quickly, that the left-hand side is cosine of theta minus pi over 3. Because one thing to remember is, first of all, this is kind of homogeneous type of equation. Cosines are together, sines are together. When they are kind of mixed up, it's usually a sine equation. And also, if you have a plus sign, it'll translate into a cosine sum difference equation as the opposite. So if you have a plus sign, then it's a minus sign. Kind of, I don't know if that makes sense, but this is definitely going to help you remember what is going on, okay? Or remember these formulas. Obviously, I didn't have to go with this. I could also do it slightly differently, and guess what? I think that's going to be a better choice, and I'll tell you why. So I'm going to go ahead. This will work, but I still need to, I still need to convert this cosine into sine, right? So that's going to take a while to do. So why don't we just back up a little bit, right? And turn this into a sine equation on the left-hand side as well. So for that purpose, I'm going to go ahead and erase this and change these slightly. So instead of sine pi over 3, I can write cosine pi over 6. And for this one, I can write sine of pi over 6. And the reason behind that is simple. I want to go ahead and use a heterogeneous equation like this one. Let me rewrite it. Sine of 2 theta equals sine of theta times cosine of pi over 6 plus sine of pi over 6 times cosine of theta. Does that make sense? Hopefully this is going to be better because we're going to have a sine equation on the right-hand side. And what does that tell you? Sine theta, cosine beta, sine beta, cosine theta. That is sine of theta plus beta. Plus will be plus with sine equations. So this is actually sine of theta plus pi over 6. By the way, the other way we do it is cosine of pi over 3 minus theta. And notice that these two angles up to 90 degrees, which also verifies that what we found is accurate. Okay? But this is good so far. Let's go ahead and proceed with the solution. Now, what do you make of this, right? When you have something like this, obviously, you're going to set these equal to each other. So first solution is going to come from 2 theta equals theta plus pi over 6. And of course, there's a 2 pi k component. You can add that. It's not going to make a huge difference, but theta from here is going to be pi over 6 plus 2 pi k. Okay? Wait a minute. This is not the solution because we're looking for x values, and x is 1 over cosine or secant theta, right? So from here, x is going to be 1 over cosine. And if you remember, cosine of 30 degrees is root 3 over 2. So this is going to be 2 over root 3 or 2 root 3 over 3. That's going to be one of the x values, which will be hard to guess, right? Now, the other branch is going to be slightly different because you have a sine equation. Here, what you need to do, you kind of need to take this, right, and subtract this whole thing from pi. Why? Because if this is, let's say, beta, sine beta, and sine pi minus beta, which is also 180 minus beta in the degree world, they're equal, okay? So with the sine equations, we kind of set these equal to each other, and then we take one of the angles, doesn't matter which one, but I'll take the second one. We subtract it from pi, so it's going to look like this, okay? And then obviously you can add the 2 pi m because k and m don't have to be the same integers. Now, this is going to give you something pretty interesting because you're going to add theta. It's going to give you 3 theta. And then pi minus pi over 6 is just going to be 5 pi over 6. And of course, that's 2 pi m. m and k are integers, I think, needless to say, right? Great, now let's go ahead and divide everything by 3, and that'll give us theta equals 5 pi over 18 plus 2 pi over 3 multiplied by m. Great, now from here you can obviously find more solutions, such as if m is equal to 0, theta is going to be 5 pi over 18. This is for m equals 0, obviously one of the solutions. And since x is equal to 1 over cosine theta, you kind of need to look at it in cosine 5 pi over 18. But what is cosine 5 pi over 18, right? We don't know, because it is basically 50 degrees, and we don't really have, or do we? That's a good question to answer, right? But we can basically just write it as secant of 5 pi over 18, and whatever that value is, you can find it. And of course, there's going to be more values. We already talked about 2 root 3 over 3, but more solutions are going to be coming, like secant of 5 pi over 18. That's we already talked about. The next one is going to be 12. I think that's going to be 17. I have to add 12 because 2 pi over 3 is 12 over 18. So the next one is going to be secant of 17 pi over 18. By the way, this is close to pi, but it's not exactly that. And then yet another one will be secant of 29 pi over 18. And again, these are really weird values, but they all differ by 2 pi over 3, because as you can see here, that's our increment every time, okay? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out the SyberMath Shorts channel and my channel that focuses on complex numbers, aplusbi, and bye-bye.